I welcome back everyone for the second very interesting technical session on emerging technological trends in passenger demand forecasting. May I now request the speakers of the session to kindly join the dais, please. Dr. Amit Kumar Jain, Director Operations and Services, Delhi Metro Rail Corporation, who will be the moderator also for this session. And then Dr. Jaison Paul, Vice President, Rajagiri School of Engineering and Technology, Kochi. Shri Sanjay Kumar, Director Systems, Kochi Metro. Director Niels Van Oot, Associate Professor, Delft University, and Co-Director, Smart Public Transport Lab, Netherlands, who will be joining us online. Shri Asit Kadyan, Deputy Director General, Department of Telecommunications. I would now take the opportunity to introduce a very distinguished personality who is the moderator of the session, Dr. Amit Kumar Jain. He is the Director Operations and Services of Delhi Metro and IRTS Officer of the year 2000. Dr. Jain has over 2 decades of experience in numerous key leadership positions. Prior to taking up this role, he was working as General Manager, Center for Railway Information Systems. Earlier, he had also worked as the Head of Operations for the Delhi Division of Railways and as Director Railway Board. He is a gold medalist from IIT Roorkee. Dr. Jain has authored books titled Excellence in Metro Operations and Management, Best Practices World Over, and many more. Sir, over to you, please.
Thank you.
Thank you, sir.
Good afternoon. Very warm welcome to the second session of the conference, which is Emerging Technologies Trends in Passenger Demand Forecasting. This is natural extension of the earlier session, which was on advancement in data collection and analysis for passenger demand forecasting. Today, we are witnessing rapid technological advancement in all spheres of our life. Today, you will see that your mobile phone is more powerful than the onboard computer of Apollo 11, which was used for first man moon mission in 1969. So that is the power we have in our hands today. Transportation sector is, of course, also pacing with the technological advancement, and we are at the crossroads of emerging technologies like AI, ML, IoT, big data, for which in the last session also we had lots of discussion. These technologies are, of course, transforming the way we operate and manage our transportation services. And these technologies can be very well used for improving the demand forecasting for passenger travel demand. Our esteemed speakers here will guide us through these transformative technologies, trends, offering insights into tools, methodologies, and strategies that can be used for passenger demand forecasting. As you would have gone through the proceedings of second session, we have very interesting presentations on data analytics platform for demand forecasting, innovation in public transport demand forecasting, unleashing mobile network capabilities. I know you are waiting for speakers to start. I'll not take more time. At the outset, I would request Dr. Jaison Paul Mulerikkal. Just I'd like to introduce him. He's Vice Principal and Professor of Information Technology at Rajagiri School of Engineering and Technology, Kochi, India. He is a civil engineer by profession, and he acquired masters in information systems from RMIT University, Melbourne, Australia, and subsequently also received PhD in high performance scientific computing from Australian National University. He had worked as a computational scientist at New Zealand E-Science Infrastructure at University of Auckland, New Zealand. He was principal investigator for a research project that developed a data analytical platform called JPDAP, that is Jaison Paul, a data analytics platform for Kochi Metro, with financial assistance from Department of Science and Technology, India. He'll be talking about this platform, JPDAP platform, an intelligent data analytics platform for demand forecasting and future trends in prediction for metro rail systems. He will also be joined with Dr. Sanjay, who is Director Systems in Kochi Metro. He is 1992 batch S&T officer. He has earlier worked with Kolkata Metro also. He has worked as Chairman Railway Recruitment Board. Over to Dr. Jason Paul. Thank you.
A warm good afternoon to all. First of all, I would like to thank iMetro organization for having this very wonderful, pertinent conference, and also to Mr. Rajneesh Ganaji, who invited me to this conference. Such a wonderful personality. I think they contacted Kochi Metro, and the MD Loknath Behra straight away called me and asked me, "Can you just come and maybe share my thoughts in the conference?" I said yes, because I think this is the first time a conference on metro data is happening. And we are, I'm from Rajagiri School of Engineering and Technology, and we are having a long-standing relationship with the Cochin Metro, because Cochin Metro became operational in 2017. I think KMR started in 2013 or something, but starting operational in 17. But then we had interactions prior to that, and we signed an MOU with Cochin Metro, especially on data sharing and all. Because without the data, we cannot do anything, and data is the new fuel, as we all know. And so then eventually we submitted a project to Department of Science and Technology, and we got a project, funded project sanctioned. And so this is a team that worked behind this project for the last maybe 4 to 5 years. And as a result of this project, we have developed a platform, and that platform is called JP And this is a kind of a dashboard for the platform. But there is a lot behind this platform. As you can see, we imagine that the data from metro railway systems will be a big data eventually. So we designed this platform in such a way that we put Hadoop infrastructure as the base of it, and on the top of that we got other modules. We are not going into the details of the architecture of uh, the platform, but the conference is based on our conference is basically on the forecasting models. So what are the things that we have done on this one? And we think that this is a kind of first kind of effort from India. So a kind of Make in India initiative, and we keep it more open source rather than proprietary. And when we talk about the platform, we start with the data. So what are the data source? There are so many data source that is available in a metro. The JP DAP is designed in such a way that we can incorporate, we can absorb all kinds of data, including the video, images, etc. But still, for this particular project, we are looking into the AFC data or the ticketing data. And we know that there are cards and then paper tickets available, and we get the origin, destination, all of the details through this data. And now um, we envisage this data or categorize this data into two. Basically, we say that there is a real-time data as well as a historic data. And how do we actually do analysis? So data analysis is one part, the machine learning or the prediction is the second part. And the data analytics, we got the extraction as well as we got the visualization. So visualization is an important factor for the management, or those who are in the behind the screens. They want to see what is happening. And the other one is, can we actually get the trends and forecasting, etc. Okay. Now, forecasting models. There are so many models available. We don't want to rework on so many models. And in the industry, as you can see, we got regressive models as well as then machine learning and AI deep learning models available. So on the left side, we can see the top models that is available in the industry. And as part of our project, we have we have experimented with at least some of them. Uh, and as you can see, we got some autoregressive models. I will explain that why we have taken those decisions. Then ANN, then LSTM, then spatiotemporal LSTM, station memorizing LSTM, because these are variants of LSTM, and then GREM. Okay, now when we approach this data, basically the ticketing data, first we took a sample and then done some experiments, and we tried to find out which kind of model, an algorithm that we need to use. Then the regressive models, we gone for that, and we found that the regression, as you can imagine, may not be the right candidate, because that is the result that we got when we did the comparison using the different parameters like mean square error and mean absolute error, etc. So that is a standard process that we all do. So that was our first inference. We cannot go in that line. And then what is the next one that we have to do? Okay, so we've gone for the ANN, so that means artificial neural networks, and then we applied. What we've done is we got the historic data for nearly 3 years before the COVID. So after the COVID, the model is invalid, but before COVID, we got at least 3 years of data from Cochin Metro, and we generated models out of this data using our algorithms, and then we applied this model onto a 6-day window and then projected it for the next day, and that is the focus for the next day. So we will get a prediction for the next day. And what happened was, okay, where is the machine sitting? Okay, yeah. Okay, then we found out that LSTM has the more accuracy, and we have done the regular ones like SPR and other regressive models and regression tree, etc. Finally, the more resolution that we get is in LSTM, long short time memory, and so we gone for that. And then the results we have published in the peer-reviewed journals, one of the top ones like IEEE Transactions, and it is peer-reviewed. And the resolution that we get, accuracy that we get is something like more than 90%. So that's what because we got the entire 3 years data. So there is a training set, and then we can convert that with the data in the next months. So that's how we validated the result. And for the pre-COVID models, we got an accuracy up to 90%, which is a good thing for general cases. And then we continued our experiments to improve the accuracy of this model. And that's why, as you can see, we found out that we got the assumptions like the spatio-temporal aspects of the data. For example, there are stations nearby, and if we can actually take the stations nearby together, that will give a better result. And then there is something like station memorizing, because we know that from, for example, Alva to Idapalli, there is always a huge traffic. So if we can input this particular feature into our algorithm, we get better results. So we experimented with different models, and all these works we've been actually able to publish, and we are getting, we are improving on our models. That is what I want to tell you. And then came, now we are working with the Cochin Metro, and then they also watched the results, and now we are running this platform, one instance in the college and the other instance is in Kochi Metro in their server. And then they came, after the interaction, they came a kind of request from Kochi Metro. We want to see at least few more days for forecasting, not the next day. can you actually expand it to maybe 3 days? So that was a challenge for us. So we did a very basic thing like, we predict for the next day and we get the data for the next day. We make another iteration using that data. Likewise, at least for 3 days, we give a kind of prediction at the moment. Uh, we need to improve this model, but still, these are this is how we think because we are working with the metro on a day-to-day basis. So that's why we are able to make these kind of improvements. So now we are predicting up to 3 days. So that was one. Now, when we did that, then there came another request from Cochin Metro, even from the MD. Okay, if you can do for 3 days, but we need it for maybe 1 month, maybe couple of weeks, and even maybe for a couple of years. But then years, we said that that may not be that easy for us at this stage. But can we actually predict it for maybe few more weeks? So then we found out that the ANN, artificial neural network, that model is not applicable. We cannot do that because when we did that, then the problem is the curve actually flattens. After sometimes there is no change. That means the predictions are not good. Then we gone back to regressive models, but then auto-regressive models. This is something like a reverse expanding moving window. So we've done something technique like that, and we looked at each day rather than a week. For example, Monday has got its own pattern, Tuesday has got its own pattern, Wednesday has got its own pattern. So we separated Mondays, Tuesdays, Wednesdays, etc., and then we started to project. This is what you see here in this graph. So this is for Monday, and then now we are predicting up to 10 Mondays in advance, which means something like 2.5 months. And we can see that the uh, we haven't verified this at this stage. We have to validate this. We haven't done that yet. But still, I think the model looks good. But then there is a problem with that, problem with our model, which everybody knows in our team as well as Kochi Metro, they know, because the anomalous points, there is always some outliers. We know that in a public transport system, some days unexpectedly, for example, there is an ISL match or maybe a shopping event in a mall, then it goes up. We cannot capture and we cannot predict that. So that is missing in this model. And this is something, we can see that always these data points. So we are working on that one. We are aware of this problem. And this is what we are looking at, working as a second phase of our project at the moment. For that, what we have done is we are working with the Kochi Metro. We need to get this data, how this spike is happening. Only the Metro can tell that. So we have developed a calendar now, and we are sharing it with the Cochin Metro. And painstakingly, they are putting all the data, why there is a spike on a particular day, and they will put a note. This is because of a sporting event. This is because of maybe shopping event. Maybe because of weather. So these points they are marking now. So once we get that, we will be in a position, I think, to incorporate these points as well into algorithm, and then we will be able to deal with the outliers. So that is a, and here there is a graph, as you can see, there is an ISL match. You can see then the spike, how it happens, and how do we do it. Okay. And so that is the analytics part. Now I would like to shed some light on the other part, the data analytics part. This is a prediction part. This is a data analytics part. What we are, the regular stuff that we do with the platform. So from the data that is available, we get the daily reports like passenger entry, exit, monthly reports, hourly, then origin, destination, PHPDD, etc. All these from we can generate straight away from automatically. We have made it automatic process, and this is how it looks. As you can see, from 2019 to 21, the entire the ticketing data pattern for Cochin Metro, and those two gaps that you see is a lockdown period, the COVID. So after the COVID, our models have gone wrong, and I think it will take some more time to generate new models because we need enough data. And this is an hourly, how do we actually envisage hourly traffic in a particular station and in all the stations. And then we got the heat map for the passenger flow. Then I think one slide is missing. That is PHPDD, but that is not there. Or maybe in the next slide. Okay, so this is something very peak direction per hour, a variation of PHPDD. And now the phase 2, that means what are we going to do from now on? Okay. So one is forecasting based on external parameters. As I mentioned earlier, there are so many factors that affect the prediction, and now we would like to incorporate. For example, weather data. I think that is available. We are in Kochi, a lot of rain, and how that is going to affect flood. That is how it is going to affect. Then sporting events, other events. So once we get the enough data, we should be able to incorporate them. And the algorithm part is almost ready. Only thing is we don't have the data. The next part, I think Cochin Metro is very keen on. I think maybe every metro will be very keen on the gender and age identification, because we just give the ticket, and even we do not know, how many men and women, male, female. That is very, very difficult. So now that is also in the second phase. So we are using a camera to capture it and then do the analysis, etc. That is a big project that is happening. I think um, our Sanjay sir will shed some light on that one. And the other one is the multimodal one. Now Kochi has got water metro as well. And this was also in our mind from the very beginning. Kochi metro, water metro, then we got the auto rickshaws, because auto rickshaw is also working with Kochi Metro, the buses also working with Kochi Metro. So can we actually connect? We know that there is a meaning in the data between all these things. There is a connection. And how can we bring that meaning? That means if travelers, they want to move from point A to point B, there are so many options, and how they are going to make those decisions. Can we help them in their decision making? Maybe price wise, maybe time wise, convenience wise, the different mode wise. So all these things that is in the pipeline. So we are actually thinking about these things. Okay, so I think I've just given a short brief on what we are doing with the Kochi Metro. Thank you for your patient listening, and I think thank you so much.
Quite thought-provoking session on how telecom data can be used for demand forecasting. Now we can take two, three questions. Yeah, starting from.
Good afternoon. Manisha Singh, Chief Architect from Delhi Metro. My question is to you, Father Paul, and a thought for Professor Neil. We at DMRC have been facing challenges of coordinating with various state agencies and private players. You spoke about multimodal integration, and just recently I have been to Amsterdam, and I realized there was a smart card which I was traveling with, but it was only valid for state-owned transport systems, not for the private players. Um, we, since have been facing these challenges, have you faced these challenges in coordinating with various agencies, Father Paul? And if so, how have you addressed those challenges? Thank you.
Thank you for that question. I think myself and Sanjay sir will be able to answer that question. Multimodal is always a challenge, which we know. And at the moment, the water metro is working under Kochi Metro. So that is a advantage for Kochi. So both these modes are combined. Rajagiri is about to sign an MOU with water metro for the data sharing, which means those two will come. And again, I think one good thing about KMR is they are also working with the buses, private buses. I think there are 7 private bus associations working in collaboration with, I think KMRL took the initiative and put them together. So which means their data is also coming one way or other. And also we are working with the State Transport Corporation, KSRTC. We are in touch with the minister and all. And they are also willing to share their data, whatever that is available, because now GPS data is available. And then Auto, Cochin Metro again took the initiative to bring
E-Auto.
yeah, that is Ozo app or something like that. But we haven't got the data yet. But we are pretty sure that we will be able to get that. And again, we put a project to Mauha to mark the parking in the city. So if that happens, if the project is through, then we will be able to get the parking spots and the availability of parking. Then we will be monitoring the parking loads. So then we will connect parking loads with the modes. And also we got another project, and that is a project of interest, academic interest, is a blockchain-based project where we can have multi-modal tickets, which is based on smart contracts. So that means even if it is even if it is uh, managed by different agencies, the ticketing can be clubbed together and accounting can be done together accordingly. So these are the things that is in that we are actually thinking. Maybe the rest I think is
I request Dr. Neil if he would like to add about on this multimodal challenges. Dr. Neil.
Yes, thank you. Thank you very much for your question from the audience. Indeed, I recognize your point. Maybe for some context, if you operate public transport in our country, whether it's a train, a bus, or a ferry, or anything which is public transport, you need to connect to the smart card data, smart card. So all public transport is organized via one card, which is great for the passenger and which is also great for data analytics. However, we need to consider privacy, of course, and we also need to consider business interests because in some parts of the country, these companies are also competing with each other. So sharing your data is a point of attention. If you look at multimodality, the national railways in the Netherlands, they also operate a shared bicycle scheme, which is called the PT bike, which you can rent at every station in the Netherlands. You can rent a bike with your smart card. So that's well integrated. And I think it's one of the best innovations in our public transport system. However, private-owned shared mobility companies, for instance, we had Mobike at some point and Donkey Republic. I think you know them all. Many from Asia also entering the European market. These are not connected to the smart card city, and I think that's a pitfall and a challenge because if we want to go for door-to-door convenience, and if we want to go for door-to-door data sharing, um, we have some challenges there. So I agree with you that I think we have it quite well organized, but it's far from complete because of these private operators in the shared mobility industry. What's complicated are two things. They come and go. This business is obviously not mature. Companies arrive and in a year or 2 years or 3 years, they're gone again. So it's very hard to make policy in a democracy. It takes time to develop policies, as we all know. So governments cannot actually deal with these quick dynamics. And the other thing is that there was no policy in place, so there was no rule and regulations. And I think that's in the end, the solution. If we think this multimodality, this integration, mobility as a service, the promise of that, if we want that, I think the only way is to enforce it via the government, via contracts. If you want to operate shared mobility in our city, these are the rules, and that means you need to connect to the smart card system, and you also need to share your data to some extent, of course. My experience is that that's the only way to continue, but of course, that's a political debate.
Thank you very much.
Good
I think now
afternoon.
we can take
I
more.
have
Thank you very much for all the participants, speakers. The interest can be seen in the way questions are being asked. Yeah. We can take question during the break, sir. Oh, okay. Anyway, sir, Professor Sarkar. Yes, sir.
Did, and I have just, yeah. Thank you for giving me the opportunity to share my concern because nowadays I see that you generate huge amount of data through call data recordings, and this is one of the good areas to make use of the artificial intelligence. And in fact, I know that there are some researchers in Japan, United States, they have done a considerable work in converting the call data recording generated to the mobile ultimately to develop the OD metrics, and which is gives a fantastic results. So they have done a lot of work. I know some researchers in Bangladesh also has done a lot of work. But I was trying to find out that though these attempts have been made, what extent we can take this model as a successful model to go forward and validate our results with the real situation, and we can replace the conventional modeling, because nowadays we do not have time to gather data and what you call validate the data. So that is my one of the questions I thought of what you call asking these things to the from the
Thank
uh,
you. Dr.
experts.
Jason, would you like to take this question? Yes.
Thank you for the question. Actually, data, we need not collect the data because data is already there from years together. When the system came into the picture, from that day, data is already getting collected and some are other form. Only thing is that the model which we are designing, that should have a capability to accept that data. And if it is not, then probably we may have to convert those data. And there are data conversion tools also there. With that, you can convert that and you can feed into your modeling system to get the desired results.
Yeah.
We develop the model.
Sir,
There's a lot of the complexities comes. I know because the data being generated through the mobile systems, and it's huge data. That's how to get into the what do you call synthesizing the data, processing the data. Ultimately, do you really resort onto the application of soft computing, for example, fuzzy logic, artificial neural network, or genetic algorithm? If you do so, because I have done a lot of work initially using the limited data, but now we have a horizon to capture huge data. So therefore, what is the probability to see the accuracy of the results when you compare to the real data? That's my question.
ah, okay, sir. Thank you for that query. More the data, more the merrier. I think that is the principle in ML and AI. So if we get large data sets, I think we are happy with that because the models, the algorithms will work on it. Only thing is we don't have enough precise data. As I mentioned earlier, with regards to anomalies and outliers, we are not in a position still now to capture those data points. If we can able to do that, then I think we'll be able to do. And big data, we got the Hadoop infrastructure, etc. We can hold the data. That is okay. But then pre-processing, etc., we got challenges, but I think we can manage it. So I think data is not a problem, getting data, but then refinement and other things, pre-processing, etc., we got challenges, but we will overcome that. And again, one thing I think I have to add to what Asit sir was telling, we need to have a system where we can ask questions and get the responses. And that is why we got this platform, JPTAB. That platform, we got APIs. That is in our mind. It should be open to public and other agencies where there are certain APIs. They ask questions about the data that is with the Kochi Metro and other modes of transport. They cannot get hold of the data, but they can ask questions and they get the results back. And I would like, sir and others to take some initiative to bring a framework where we got some kind of standardization for these kind of APIs. That is what we are looking at. Thank you.
Thank you very much for questions. And let me just summarize the sessions and then we'll break for the lunch. Dr. Jason, thank you very much, Mr. Sanjay, for insightful presentation on the JP depth model. You illustrated how historical data and ASC data can be used for demand forecasting using artificial neural network for short-term forecasting and autoregressive model for long-term forecasting, and how it can be presented in a powerful visualization models dashboards. Thank you, Dr. Neil Van Ort, for giving insight on how multiple sources like Bluetooth, Wi-Fi, GSM, traveler app, social media signaling and vehicle location data can be used for demand forecasting. You discussed about the transport model using network data, smart card data, processing this data and converging this data for the route choice and visualization option. You introduced a very interesting concept on service reliability, how service reliability can be taken into transport modeling and how it can be used to enhance the ridership actually. Thanks, Mr. Asit Kadian, for making us aware what kind of telecom data is being available, how it can be used for transport modeling, and the privacy issue involved, which are very important, of course, and how this data can rest with the owner of the data, that is the local model, and it can be used with confidence and privacy in the. And you also talked about mobility hubs, Chennai case, how hourly variation in the demand, travel demand can be seen. Thank you very, very much, all the speakers, and we are. I know everybody is waiting for the lunch now. Thank you.